Hey everyone, welcome to this tutorial where we'll walk through how to encrypt traffic between a load balancer and TCS Fargate tasks. To better understand the context, let's start by looking at how connection security is implemented at the load balancer. An application load balancer, or ALB, lets you attach a TLS service certificate to it, which enables client to start a TLS session which encrypts the traffic on the public internet between the client and ALB. But what about this connection here? The connection between the load balancer and your backend application. Is it encrypted as well? The answer is usually not. The TLS termination is happening here at the load balancer, which means that the encrypted connection ends here. So by default, this traffic within the VPC between ALB and the application will be left unencrypted. So why bother encrypting traffic within a VPC? Well, there are a few important reasons. First, compliance. Many regulations like GDPR require end-to-end encryption, including your internal traffic within your infrastructure. Secondly, it's a best practice to assume that your internal traffic can be intercepted. Encrypting this traffic ensures that the intruder will not be able to read the data that travels between the nodes. And lastly, in certain scenarios, you will have to share your VPC with third-party organizations, and you will want to protect your data from them. Alright, so how can we actually encrypt internal traffic within our VPC? There are two main options. The first is using AWS Private Certificate Authorities. This is a robust, fully managed solution, but it comes at a high cost. Each CA is around $400 per month, so if you're using both intermediate and root CA, you're looking at about $800 monthly. That's a steep price just to encrypt internal traffic, and it may not be cost effective for many teams. That leads us to the second option, which is the focus of this tutorial, using self-signed certificates. While this approach doesn't allow the ALB to verify the identity of the services it communicates with, as it would with trusted CAs, it's much more budget-friendly and still provides strong encryption for internal communication. So our plan is to deploy 2 containers per each task, the actual application container with the Envoy proxy sidecar container that will be having a TLS certificate installed on it and will be terminating the encryption between the ALB and the proxy container and forwarding the traffic to the application unencrypted, which is fine because both of these containers are in the same host. Here's the plan for this tutorial. First, we'll deploy the AWS infrastructure, including our load balancer, ECS, and all the supporting resources. Next, we'll generate a self-signed certificate using OpenSSL and upload it to our AWS setup. After that, we'll create Docker image definitions for both the app and the proxy containers. Finally, once everything is up and running, we'll verify that the internal traffic is actually encrypted. So I will see you in the next video.